In our last episode, we saw how we can create streams and put data into Kafka. Now we want to see how we can do joins and how we can join a stream and a table and how we can do aggregations in these joins. Then we're going to also put the data back into Kafka and we'll have a great view of the potential of Ksqldb. Welcome to Programming with Matti. So in this part, we're going to be learning about joins. As in Kafka streams, in Ksqldb, we can do joins between tables and streams, or streams and streams, or tables and tables. We can do all sorts of joins. There are some rules that we need to follow. So if the join is between a stream and a stream, we can do these kinds of joins. We can do the inner join, so the intersection. We can do the left join, which is basically the intersection plus everything on the left. We can do full join, so the union between both streams. And these joins have to be windowed. So as we saw in the window chapter in Kafka streams, we had to declare windows for the streams to be joined. We cannot join all the events on a stream because events on the stream are not saved anywhere. So if we have a window, they are saved temporarily for that window period. After that, the window is reset, let's say. That doesn't happen with tables. So if we have stream table, we have a place where we save it is in the table. So the stream table, it produces a table, and you can do inner join and you can do left join. And finally, you have a table join, which allows you to do any kind of join, and it's not window. We have to have other rules into account as well. Like, for example, the columns that we use in the join expression must have the same types. We cannot join on a key that has integer value in one table and varchar in another table. So we have to use the same value. And then there is the partition count on the two sides had to be the same. And finally, it has to use the same underlying partition strategy, which usually means that you're using the default partitioner. So in most cases, you don't really need to worry about this. So let's join match event with players. What are we going to do? We're going to join so that we can count all the goals that a player has done. Okay? So let's say we want to join, we want to select the player ID, the player name, and we want to count all the goals. So we're going to count the events with this count function. So this is the aggregation. And then we're going to we're selecting from match event. We put this alias me join players p, and the join key is the player ID has to be, the player ID in the match event has to be the same as the player ID. So you can use any join key from the side of the stream, but for the table, we have to use always the primary key. And then we also filter events that are just goals. We don't want other events. We don't want assists. And we group in by the player ID and the player name. So we emit these changes. We're going to clear here so that we see the results in the middle of the screen. And as you can see, we have the player ID is 1, the name, and then we have the goals. So how many goals each player did in all the matches, which is really, really good. And now let's add even more data. We're going to be having 3 different projections. And here we have only one, which is the goals, we want two more. We want the assists, and we also want an average goal number. So an average amount of goals per match. So basically we need to get all the goals that a player did and then divide them by the amount of games that the player has played. So how do we do this? Let's see here. We have the query. So first we're going to say select, and we have the player ID, we have the player name, and we have the player nationality. And then we have our projections. Let's look at the goals first. In the case of the goals, this is similar to what we did in the past. So now we're summing 1 every time the event is type goal, otherwise 0, and we're counting goals for players because we're grouping by players. Then we have let's look here for the assists. The logic is really similar, but in this case we're checking for assists in place of goals. And now the last one, which is I guess the most complex one, is the average goals. So here what we do is we again have the amount of goals, and then we do this, which is a casting. We're casting the result of this as a double. Why am I doing this? Because I want an average, and an average is a decimal number. I don't want an integer. I want to know, let's say if a player does half a goal per game, I want to know that. I don't want to get a 0 because it's an integer division. So I do this casting, so I have double, and then I count all the different matches that the player has played. And I use count distinct because for each event, I will have the ID of the matches repeated, because the same match can have many goals. So I'll count all the distinct occasions so that it gives me the distinct amount of matches that the player has played. And then this is the amount of games basically the player has played, and I do the casting to double because again I want to do a decimal division, I don't want to do an integer division. And I name this projection as average goals. Once we are done with the projections, we can see here we're grouping by we're selecting from match events, joining with players, the joining key we already discussed, and finally we're looking at group by, and we're grouping by player ID, player name, and player nationality. So basically these 3 columns. We could avoid this and we could just use player ID. We want to display this. So there are ways in which we can display these values without having them as a grouping key, but we're not going to see this right now. For now, we're going to use it as a grouping key. So let's run this query. Now you see all the information that we have on the players. We have all the information about the players and how many goals they made, and the average goals, so how many goals per match, and how many assists. So this is really, really cool. So let's terminate this query, and what we're going to do now is let's put this into Kafka. Let's create a sync table. So how do we do this? We take that query and we use the create table command. We're going to create the table player stats for the topic player stats, and the format is going to be JSON. In here I'm not using value format, I'm going to use format because as I said before, I'm grouping by 3 different columns, right? So these columns are going to become the key. So I want the key in JSON format. So I'm going to put format here as JSON for the key and for the value. Partition is going to be 1, and then just the same query that we had. So let's go ahead and do this. Cool. So now I should be able to query this. So I'm going to say select star from player stats, emit changes, and as we can see, the data is there. So one last thing that we're going to do is we're going to be checking this data in Kafka. So let's see. In here, in another terminal, going to run this command. You see we're going to query the player stats. So let's see. Yes. So we have player, ID, name, nationality, goals, average goals, assists. So all the data that we need from the player is there. This is amazing. So I'm really happy with this. And you see all the things that we were able to do just by using simple SQL. We were able to put data into Kafka using the connector from Kafka Connect, and then we moved that data, manipulated that data. We created a different stream for the match events, and then moved that data into another Kafka topic after manipulation and joining. So the power of Kafka, the power of Ksqldb is just off the charts. That was great, right? Uh, it's amazing the things that we can do with Ksqldb, how easy it is to manipulate the data, and how we can create new derived tables and have these ripple effects that then give us this eventual consistency. So if you enjoyed the episode, consider subscribing to the channel, leave a like, leave a comment, and all this helps me to keep creating new content that we all enjoy. So thank you, and I'll be waiting you in the next episode. Bye.